probably more on the beginner side. So I'll take it a little bit slower and focus more on like explain it. And in general, kind of what I've gone through is you don't have to, I mean, it would benefit you if you did know a little bit about R. But if you don't know a lot about R, you're still going to benefit from it. So if everybody can, first off, how many people have installed Stringr and Forcats? Almost everybody. So if you haven't, please do so right now. It might take a little bit to install. Yeah, so I'll type it out. So I'm gonna open up a new file. For those that aren't familiar with RStudio, you just have to do Control-Shift-N to create a new file. So the command to install packages, and then do Stringr and Forcats. So just type out that command. Can anybody see? Is that big, or should I make it bigger? Actually, I'll make it bigger. Might be a bit too big, but oh, that's probably fine. Yeah, people in the back see okay. Okay. Sorry. Oh, yeah.
Forcats is not writable. Would you like to use it for Stringr instead?
Yes.
Thanks.
If it says that, just say yes. And so if you're installing it in the meantime, I'm going to be going over so these are R packages, and so they supplement what the base R has. They're really, I'll have a little disclaimer here. I've never actually used them in my own personal usage, but I've always wanted to. So I kind of use this chance to like learn it myself, to be able to eventually use it in my own code. And I definitely will after having looked through, after having gone through some of the stuff. I definitely will be using them. Okay, so the packages are Stringr, so that deals with strings, and Forcats, which deals with categorical variables, or both are kind of, does anybody know who Hadley Wickham is? Some people? Well, if you don't know, he's kind of like a huge deal in the R world. He creates a shit ton of packages and you can Google this, that make up, I'll even just write it up here. So tidyverse.org. Tidyverse.org is a website that contains packages that all kind of relate to, his concept is called tidyverse, so making everything kind of work together in like a seamless way. Each package kind of integrates with each other, but can also be used standalone. So it's really a powerful way of looking at how to deal with coding and data, wrangling it and then visualizing it. And has anybody heard of ggplot2? Yeah, so he created that. That was him. Okay. And so another thing that I was going to say is the nice thing about Hadley Wickham and his team of people is that they create some excellent documentation that's really aimed at like beginners. So like tidyverse.org is a great walkthrough of some of these packages. He's got a book called R for Data Science, which is also very well done. And it goes through like the whole process from kind of beginning to end of analyzing the data to to visualizing it, to presenting it, to, how do you say analyzing? Collecting data, storing it, wrangling, visualizing, analyzing it, and then finally writing it up and presenting it. Okay, so in base R, I said that I would be going over string manipulation, factor variables, and regular expressions. So who knows what regular expressions are? Okay, not everybody. I guess that's kind of good. Or bad? I don't know. They're really complicated to kind of explain. It's like a very powerful way of dealing with like picking up patterns in text, but it's very complicated to deal with. And I'll just show you an example. So, by the way, the little hashtag that I write right here, that just means a comment. So R will not interpret that if I do run it. So in regular expressions, certain characters have certain meanings. So a $sign does not mean a $sign. It means the end of the string. Uptick doesn't mean uptick. It actually means the beginning of a string. So if we do something like uptick who, regular expression will convert that into finding any single word or string that matches this pattern exactly from beginning to end. So it'll look for from beginning who to end. It's not going to find whoever or whom, it's only who. There's asterisks, which is kind of like a wild card. So it doesn't actually mean an asterisk. It's a very powerful way of saying any character could be in that position. If at any point you have questions, or I'm going too fast, or maybe too slow, just like mention it. That's kind of one of the points of like here is, yeah.
Is it any character or any string? It's a single character?
It's a single character, yeah. Is that right? I never remember.
I don't think that's true.
No, I don't think that's
not
true either, no.
Anything
It's anything after, yeah.
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 It's like these strings.
Yeah, I always get it confused. I think it's a period is any character. So this little dot means any single character. It could be anything, but only one. And then asterisk would be anything. So like if you were to do something like who dot asterisk, that would just be anything like who, anything, any word that kind of begins with who, and then anything after. So it would pick up whom, it would pick up whoever, and so on.
Asterisk dot
What?
file extension or something.
What's that?
Asterisk dot file extension.
Yeah.
I'm gonna get rid of file extension.
Yeah. This is quite extensively used in the shell. So if you ever use like the terminal, I see a lot of Mac users, so maybe you use the terminal. And so the asterisk would be quite used extensively in the terminal. And then there is, so there's period, there is brackets. So when you use brackets, this is useful when you want to search and replace something. So the brackets can be used to say, okay, I want to find who. So like in this case, I guess I can show you an example. So like if you were to do who for whom, and you wanted it to replace with, let's say, just convert everything that says whom to just who, you could say who, whom, and then one. So one would say, I want to take anything that's in here and put it in here. So it would convert whom into who. See how, can anybody see how it's starting to get already a little complicated? Just to give like an example of how complicated some of this regular expressions can be, if you ever want to like see, Google regular expressions for email addresses. You'll see something quite incredible. It's pretty impressive, just how big regular expressions can get just for something as simple as an email address. It takes up probably, well, you can Google it, check it out. Okay, so slash. In R, single slash means something. So in order for you to use, so in regular expression, this would just be a slash, a single slash, and then one. But because it's in R, you have to do double slash. That's just a small difference between regular expression in R versus regular expression in other languages. So you would have to do, so if you did want to have like an actual slash, you could just say, would you just do slash? I don't remember. There's also square brackets, which mean anything within here, but only one of them. So like if I were to do A-E-I-O-U, it would search for any string that has any of the vowels in it, but only one. It's like a A or E or I or O or U. There's also this. So a bar means or. So if you wanted to see something a little bit more complicated, let's say you wanted to do like the something that has IE or EI or IE. If you were to put it into here, this would interpret it as this or this or this or this. But in this case, you're saying, I want to find patterns that look like this, and I want to find patterns that look like this. Now, there's a little bit of other ones out there. I'm not going to get into them. I'll get into them as I go. So now for some actual R commands, there are four main regular expression commands. So G sub, well, let's first do, hold on. Let's do fruits. Apple, banana, pear. So that's just taking 3 strings and putting it into fruit. And you can run this command by just typing Control Enter, and that just sends it directly into the console. So if you do G sub, and I want to replace, let's say, Apple or AP, or let's say I want to replace A, anything that starts with A and then remove that A. I can do uptick A, remove it, so an empty string, and then fruit. Fruits. You see how it searches for anything that starts with A and then drops to A. If you wanted something a little bit more complicated, you do maybe replace it with BB. So then now, so you're saying either AN or AR, and that replaces it with BB. So that is BBBA, or PEB. Also grep. Grep is kind of the same thing as in terminal. So if anybody does use, has anybody used grep in the terminal before? Oh, most of you. Okay, so it acts very similar to the terminal. So you just do grep, and I want to find like anything that starts with A, fruits. And so it picks up. It says, in this case, it's saying the first position, but let's say I want to see the actual value. You can do
values equals true. Oh, value.
So then it takes, instead of showing just the position, because that's position 1, it shows the actual value. So in this case, it's apple. So G sub and sub are kind of like the same thing. I'm not going to show examples of them because I want to get to some of the packages. But G sub and sub, G sub is G for global, so it will replace everything in a string, and then sub will replace only the first instance. So if you were to use A, it only replaces the first A. And then grepl just stands for grep logic, so it just converts it into a logic string, which you could use in, like if you wanted to filter by a certain string or pattern, you can use grepl. So far, how does that? I mean, like regular expressions are kind of sometimes challenging to deal with in the first place, but how is that so far? Raise your hand if you kind of understand it. Okay, that's good. Raise your hand if you really understand it. Really? Wow, that's okay, that's good. Okay. So I'm gonna go then to library, the Stringr. Stringr is just like a much more formalized way of using regular expressions and manipulating strings. It also, so when I learned a little bit of Python, I realized like that in Python, like the strings, individual strings can be broken up into like individual letters, which is kind of cool. Like a base R doesn't have that, but Stringr like kind of supplement, kind of bypasses that limitation. So you can actually pick up individual strings with individual letters within a string. Does that make sense? Is it letters or, yeah, okay. Or characters, there, that's a good word. Characters, thank you. Okay. So if you ever want to look at what is inside of Stringr, the package, if you do Stringr : it lists all of the commands within Stringr. So you can see, like I'm not going to cover nearly all of this stuff because it's quite a lot. There's about, I think, 42 different functions within Stringr, and they do some pretty powerful stuff. So if you do want to like go into more depth, again, there's the documentation that's there, but there's also this this way of accessing it. Okay, and if Stringr doesn't have, who does some like stuff that's quite intensive in string manipulation? Does anybody? Couple? Okay. If you ever do, like if Stringr doesn't suit your needs, Stringr is based off of Stringy, which is another package, which is even more comprehensive than Stringr. So like that has everything. I've never used it before. Okay. So the first thing is I'm going to create a string variable with month names. So month, if you look at it, it just contains months, names of the months. So some common things that you might be interested in is every single, pretty much every single command within Stringr starts with str. So str_. So it kind of makes it easier to search for things. So Stringr to lower
what that does is converts everything to lowercase. So in that case, everything gets converted to lowercase. String to upper converts everything to uppercase. If you want to look at the individual lengths of each string within the months, you can do.
Oh, that's going to lower. So like 3 is May. So May has 3 characters within its string. 7 is January, 8 is February, and so on. So you can like kind of break down how big each string is. In base R, you don't have that ability to do that, at least as far as I'm aware. If you want to concatenate all of the strings together, you can do string collapse equals. So let's say I want to put commas in between each month. So that puts commas in between each month. So January, comma, February, comma, March, and so on.
String subset is if you want to, it's kind of like grep, except a lot more powerful and faster.
So string subset will take any month that starts with J. So January, July.
Or if we wanted anything that started, actually everything started, oh, no. Subsets, month, anything that ends in Y.
January, February, May, July.
Or subsets. If you want to see if anything has
Either an S, an N, or a D. So it'll search for anything that has any of those strings.
characters. I gotta change that.
Except, wait a second. Doesn't September have an S? What?
Case sensitive.
Yeah, case sensitive.
So one way of dealing with that is just do string subset, string to lower, month,
There we go. Now you have September, since we know that has an S, or and November, because that also has an S.
If anybody is familiar with pipes, does anybody use pipes? Okay, good. Pipes are really a powerful way of kind of looking at the logic of a sequence of commands. So in R, if you do Control-Shift-M, it'll create a pipe. So the reason why it's called M instead of P is for the original package that created the pipe, which is called Marit. French. And so you just do pipe, and then you convert to, so string to lower, pipe, string subset.
So So like this is the same as this, but this, I mean, maybe it's just me, but this seems like it's easier to read because it's in the logic of it. You take the month, you convert it to a lowercase, and then you subset it. Versus you subset converting to lowercase months. It's like a little backwards. So this way of doing things, and this is another this is another thing that falls under the tidyverse. Is like pretty much every single package within the tidyverse follows these types of rules. Is use the pipe to go to the next thing, 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 rather than the base style way of doing things is this. Maybe this is more of an opinion. Who thinks that this is a little bit easier to read than this? So this is easier? Okay. This is easier? Huh? All right. Well, you did say that data table was easy to read.
So, you have a shortcut like hack?
For this? Yeah, like Control Shift N. So it's Command, yeah, Command Shift M if you remember. So another thing is called string detect. And so if we use fruit, so in this case, use fruit instead of fruits. This is another, so fruit, anything that starts with BE. So I'm thinking maybe like a berry or something. So this converts it into a true or false. Right now there's nothing that contains, oh, there's one true. There's one true that starts with berry, or BE. And if you wanted to find something that's maybe, so this is useful, string detect is useful for, it's kind of like grep so grep logic. So it just converts it into a logic string so you can like filter things or use that within other operations that you might be doing. So fruit again. So let's say this time anything that starts with A, E, I, O, U at the end of the word. There's a lot more that starts with A, E, I, O, U, that ends with A, E, I, O, U. And then we can actually, oops, type this to mean, for example, to find out what the proportion is. So 35, so that's 35% of fruit ends with this, ends with an A vowel. So it's just a kind of a quick way of just finding the proportion because in our logic gets converted into 0 or 1. So 0 or 1, anything between 0 and 1. The mean of between 0 and 1 is the percent of what it is, if that makes sense.
Is there anything you can do with that? I wanted to ask, use 2 vowels.
At least 2 vowels? Ooh.
Something like that.
Yeah, okay, let's do at the end or like in the word somewhere? Okay. Without doing what?
Without actually ordering.
Yeah. String detect. String detect. Fruit. You said, say that again.
Like at least 2 vowels.
At least 2 vowels. So you could do A, E, I, O, U plus. So that says, I think that's 0. What? It would be at least 1. I think you have to do this. 2? Find out. That's a good question. So the first one is at 26. 26 dragon fruit. Did you say 2 in a row or?
I guess 2 in word anywhere, not necessarily.
Should be 9 too. 6, 7, 8, 9. Yeah, this works.
So like blood orange, it picks up, that converts to true. So blood orange has 2 vowels. Is that what you were saying?
That's only because there are 2 words in a row.
But chili pepper doesn't work.
So 2 in any case,
Yeah, 2
anywhere.
anywhere.
So I mean, it can be done because it's regular expressions.
Maybe the 2 another square bracket of vowels again.
Put 2 square, 2 of the vowels, or dot, sorry.
2 of the vowels and then do dot star and then another 2 of the vowels.
And then the right?
Oh yeah, that would work. Yeah. Yeah. That's a little.
Which is that just gets exactly 2.
Yeah, that just gets exactly 2. Yeah.
Exactly
No, that's-
2 or more?
No, that's 2 or more.
How are you going to decide? No, that's.
Oh, yeah.
Because the dot can match anything there, so.
Yeah.
it could be another dot.
Everybody see how this gets really complicated? Again, look, Google, email address, regular expression. You don't know what's going on. Okay.
Yeah.
I mean, it's regular expressions are really. What were you gonna say?
You didn't mention knots. It's very fast.
Knots?
You use a verb in not vowels.
Yeah, not vowels. I think that would just be an exclamation mark.
That's scary.
It's which? It's a which?
Scary, sorry. I don't know how it works. So.
What is it again?
Like, I'll take it. Sorry.
I thought it was an exclamation point.
Yeah, I thought it was.
But that's not matching the entire script. I mean, just not matching the third.
Not sure. I don't know.
Put uptake before the A.
Uptick before the A here. Like that?
Yeah. I mean, that'll be all true because everything has a consonant, but I don't even know what the
Maybe anything without an A?
Yes, right.
Everything has without an A?
Everything
No.
will match not an A, right? There's at least one character that's not an A.
Right. So maybe if we do something like this. No, this.
Put a dollar sign in it, try that. Take out that side. So anything that doesn't end with an
Okay.
hopefully it'll be something.
Most stuff. So number A. Oh yeah, I guess I could do subs. Wow, not thinking today. Okay. String subsets. Let's do this the proper way. Fruit. There we go. Okay. Doesn't end in an A. Yeah, nothing ends in an A. There you go. That's not. But it's kind of complicated. I guess you don't need this part here. Yeah. Okay. Okay, if you want to replace, so string replace, month, let's do month because it's shorter. Replace anything. I'm going to show a little bit more of an example of using the brackets. So anything that so there's only one that I know of that should end in E and has J. and that's June. So I'm going to do 1. Hi. 2. Oh, sorry.
So this is what I was kind of saying is, so using this, you can do even more complicated stuff. You can include like regular expressions within that. And so you can say, I want to preserve J and I want to preserve E. So that's 1 is the first one, so J. 2 is the second one, that's E. And I want to replace whatever is in between those with I. And that gets converted to a job. So that's I mean it's a very toy example, but like you can do some pretty powerful stuff with that.
What's the, you have the double backslash before the 1, but then you have the 1 and the I next to each other, and then it again with the 2.
So this is like special. So when you do // that R interprets that as one thing, and that interprets it as this. And same thing with this, like //1, it interprets that single as a single thing, and that gets converted to that.
Oh, okay, so it's, all right.
Yeah, so you need to have the //
Because if you were to do without the slash,
it just gets converted to /00. So it preserves it. So you use the slash, you use double slash to tell R that you're using a command now.
And you can tell that 1 I, it recognizes the 1 and then have the I, something so after.
Yeah, because that's a single, like this is a single entity. It's
Yeah.
just like if you were to have a backtick in front or whatever, like that's a single entity. It doesn't matter if there is a space or not, it's like a single entity.
Let's say you have, so there's a thing in a thing to work with called sentences. So if you do this, if you run that,
Has a whole bunch of sentences, just random sentences. She saw a cat in the neighbor's house. A pink shell was found on the sandy beach.
just random stuff. Now, if you want to split those sentences, so let's say we want to split the sentences. In this case, anything that has, so we want, instead of sentences, I want individual words. So anything that is with a space in between, I want to split it. So it's a single thing. And because there's a whole, like there's 720 sentences, so I only want to kind of extract the one. So I'm going to do 1. So that's 2 brackets, and that's extracting just as the first item within this split. So if we run that,
that splits this into the birch, canoe, sled on the smooth planks, period. But I don't necessarily want that period.
so there's a command in here called, so if we do sentences, boundary, word.
If we want to run that, it splits the sentences up by word and dropping the dot. So that's kind of useful if you specifically know what you want to, you want specifically words and not necessarily anything that has a space in between.
If you want maybe a little bit more, if you want maybe sentences, individual sentences, I think it's just sentence. There we go.
So that's the first sentence. Birch canoe slid on smooth planks. So that's the first sentence. Because before it was one single character. So sentences, the command sentences is a single character of, how much was it? 720.
Why are you doing double bracket? I have the same thing.
Huh?
Why is it double bracket?
At the end?
Yeah, why is it not single bracket?
Because what string split does is it converts it into a list. And so using double brackets accesses the first item, the first list item.
So the only reason I'm seeing the same result is because we're only getting one list after that.
What?
Like if I do one.
You do one.
Right? It's that first.
Oh, it still works. I guess that's the first. What if you were to do 2? Huh. Well, look at that.
I think if you do like single bracket, it's gonna return it as a list, but if you do
With
double
double
bracket,
brackets.
extract it as
As a single, yeah.
yeah, so then
Yeah.
you can, it's just extract.
Yeah. Yeah, you're right. Because here, you can see here, the difference is it says 1
Yeah.
when you're using double brackets.
And then you see the double.
And then the next one is, it's,
This is a list.
so it's, you're preserving, so this is a list and this is a character. Character.
That's why. You got it.
And if you wanted to, am I going too fast? No? Okay. Oops. Always a worry. Going too fast. So if you wanted to convert that into idle case, for example,
So again, like this is kind of the nice thing about using the pipe is that you can just add it to the end and then it'll send it to the next thing rather than having to add string to title at the very beginning and then add the thing to the end. So it's very easy to just insert new commands within a pipeline. And so string to title just converts to title case, so capital letter of each word.
okay. Let's do, I'm gonna go to the next package. Is anybody interested in keep on learning about Stringr or the next package? Next package? Okay. Forcats.
It's kind of cute. If you look at the GitHub page for Forcats, there's literally like 4 emoji cats in like the README of the documentation. Forcats. That's cute.
Okay. So again, you're going to use month. So in R, there's a way of converting something. So month right now is, so if you do string month,
It's a character variable. Character class. Yeah, class. Thank you. Character class.
in R, the base functionality is called as factor, so month.
And so it takes this as factor and it converts it into a factor and then it shows, so now this is a factor variable rather than a character variable. Class, factor class, not a character class. And so this is what is contained inside. But if you'll notice, it says 12 levels, April, August, so on. It's in alphabetical order.
which is not always a good effect that you want. You want it, like more likely you probably want it, you want to choose how the ordering is. And likely it's the order that it came in rather than the order that is decided by as.factor. So in Forcats, there's as factor. The only difference is one has a dot and one has an underscore. So it can be a little confusing sometimes, but this has an underscore. So as factor, and you'll see here that it preserves the order. So that's useful if you want to say you sort it beforehand and then convert it into a factor, rather than try to wrangle it at the base end and let it do its thing. It's just, this is the effect that it has, and that's it. Okay. I'm going to create a new variable. I'm going to call it month, and I'm only going to take the last 2 months. I'm only going to take the last 6 months. And then I'm going to just take all of the months. Oh, C. There we go. So month now starts with October, November, December, and all the way. And this is again a character class. So you can do, so in Forcats, almost every command starts with FCT. So FCT for factor. In this case, I want to, there's some pretty cool functions in here. So for example, if I want to organize it as a factor, let's say by frequency, month 2. So factor in freq means that it orders the variables by how many factors there are. Sorry, how many of December, for instance. So December I know has at least 3 instances in it because I decided there's 3. So it orders, that's the first variable that it's going to put it in. So December and then all the way down to May, and I know May has only 1 instance of it, so it's in order by the frequency. If you want it exactly in order, the first instance is October, and the first instance of the level is October. So it preserves whatever order you're getting it in. So fact in order, same thing as factor. Another one that's kind of nice is if you just want to count how many instances there are. So it lists off however many, so it counts. It's kind of like a quick summary of what's contained within that variable. You can see that it lists off. So as I said, December, 3, and so on. And you can sort it. So if you want to see from the most to the least, again, December has 3, October has 3, and all the way down.
So I'm going to bounce and using that with the table.
Pardon? Advantages, I would say the advantages of using this or like table would be that this allows you to use it within the context of a pipe, while table doesn't really let you use it in a pipe. So like you can use this in, like you can use it more in the context of the tidyverse, while table kind of requires you to jump outside of the tidyverse and the pipeline.
Pipes are only for patches.
Sorry?
Pipes only for patches that are part of the patches.
No. Because the table wasn't created to be used pipe, but all the tidyverse packages were used specifically in the context of the pipe. So it's just different. Like, I mean, you can still use it in a pipe, but you just have to do some extra steps. That's all. There's one here that I found is really interesting. Oh yes. So fact lump. This one is really really useful. I've done this a couple times for my own work. I've never used this, but like if I had known about this, I would have saved myself some time. So if you do fact lump, so what fact lump does is it. So sometimes when you when you encounter variables that, in this case, for example, there's only one instance of January, one instance of February, and you have maybe 1,000 data sets and 1,000 variables, and everything else is like 500 or whatever, and you have only a couple that are not in those big categories. Sometimes you convert them into other, right? At least that's what I do. Like for example, within my data set, there's like ethnicity, and so there's some ethnic categories that are very tiny versus like the other categories. So it's easier just to clump it into others statistically. And so fact lump does that for you. So like let's say I want to lump anything that is yes. So anything that meets the threshold of, in this case, 1. So if there's only 1, then it converts it into other, which is kind of nice. Like you don't have to do the whole work yourself; it just does it for you. You can say maybe if it's if it makes up I think this works like 30%. No, would this work? Oh, proportion. So that's 30%, which is, I think, there. So if it makes up 10% of the overall, then it gets. If it doesn't make up 10% of the overall, it gets converted into other. So in this case, only November, December, and October are kept, and everything else is kept as other. So some pretty useful uses there. The other one too is if you've ever recoded factor variables from like let's say somebody mistyped a particular variable and you're like, ah man, like this was entered wrong, so now you have to deal with that. Or maybe you just want to rename them. So you can do fact recode month 2, and then you just continue off. So let's say I want to call it January, Jan instead of January. Feb instead of February. And that's it. Like, let's say I only wanted those 2. I converted it into January versus Jan instead of January. Rather than oftentimes you'd have to do you'd have to relabel all of them. If you do like factor, level, and label like all of them, which is kind of irritating because then you have to know the exact ordering, or you do a series of like if-elses, which is also annoying. This way, it's just this. There's if anybody uses the package plier, it's very similar to map values, I believe it's called. So plier map values is very similar to this, but this is specific to factor variables. And if you want to include something that maybe has a space or something, I think you can just do. I think you can do this. Let's see. Yep. So if you wanted like to include spaces, for example, or other characters, like you can just do quotation marks, and then it'll get converted into that. So that's the new, this is the old.
Is there some kind of fuzzy finding possibility you say, or would that be a completely different?
Say that again?
As fuzzy finding, like
Oh, fuzzy finding.
correct spelling mistakes, for example. Or is that completely different?
I believe, as I was looking over like some of the documentation, it did go into that. I don't know how to do it offhand, but there was some talk. I think there's like this one command. Oh, no, that's in Stringr. Col. So that does kind of fuzzy finding for you. But that's, I think, more in Stringr rather than in Forcats. Yeah, there's a bunch of other things available in here. I don't know how much. It's kind of time. Does anybody have any questions? More details or something. Like if anybody has any questions, maybe I can go into like a problem that they have or that they've done, or you can just leave. So whatever it is. And I'll be putting the code up online too. So if you have any, like, if you want to look it over, or if you have any questions too, you can also ask inside the events issue if you follow on GitHub, which you should. Does anybody know what GitHub is? Yeah? Oh, not everybody does. Ish. We should have like another intro to this.
Yeah, that's what
Yeah. Yeah. That's it. Anything else? So I don't have too much. And there's a lot here, but I know, like, if you do want to go into more detail, there's. I should just show the R4DS. So this is the book that I was telling you about, the R for Data Science. It really is like quite well done.
is it free online?
Yeah, it's free online. Yeah. So it goes into like wrangling. It goes into, so a lot of it, like strings, for example. This is where I got some of the stuff to do this. It shows how to go into, where's the type? There's the factors. So one really powerful use of using the Forcats within like a pipeline and so on is when you eventually pipe it into let's show an example here. Yeah, so like I know for myself, I've done this quite a bit. Is like I have a factor variable and I want to plot it on like for whatever case, and so then I kind of have to do a lot of work like wrangling myself and like forcing R to stick with the thing and then plot it, and then it goes into the order that I want. So like for example, like I will have maybe in my case like fatty acids, like specific fatty acids on one of the axes, and like the fatty acids are in, you know, they're in a bunch of numbers, oftentimes numbers, and I want to get it into a specific order, and oftentimes I just have to like literally list the fatty acids in the order
that I want it. But with the Forcats, you can use it within the ggplot2 within the pipeline to be able to get to how you want it, rather than have to like kind of fight R to be able to get it as you like it. Again, kind of what I was saying is you can use it within the pipeline. So mutate is like a dplyr package, also very powerful. If you haven't used it before, you should look into it. And you can use it within that context, and then again send it off to be plotted. There's no plot there. Yeah, anyway, there's a lot of uses for it. Other than that, I'm done talking.